Hi everyone, we continue TERENGGANU paper 2, fire 2022, section B and section C today. We'll look at question number 9. Diagram shows a glass of water cooled by some ice cube. The process involves specific latent heat of fusion. So it means the concept is already given here, specific latent heat of fusion. What is meant by specific latent heat of fusion? So ini definition memang kena memorize lah. Amount of heat required to change 1 kg of solid to liquid at constant temperature. Okay. For freezing or melting using latent heat of fusion. So you need to memorize, very important here, you must take 1 kg of substance, solid to liquid, constant temperature. B, using the concept of specific latent heat, explain how ice cube can cool drinks more effectively. Okay, there will be heat transfer between ice cube and the drink. Ice cubes absorb latent heat of fusion from the drink when ice melts. The heat absorbed is used to weaken the bond between molecules of ice cube. Thus, ice cube melted, and the drink is cool. The drink cools. Okay. Okay, so I have point here. So we should write in the space given. So just write here so that we can refer to the question. There will be heat transfer between ice cube and drink because ice cube has low temperature than drink. Ice cube will absorb latent heat of fusion from the drink. The heat absorbed is used to weaken the bond between molecule of ice cube, thus ice cube melted and the drink cooled. This is because the heat loss from the drink used to overcome or to weaken the bond so that the process of melting can occur. Okay, so you have 4 points. You must include 4 points here. You can see there are 4 marks here. But C, calculation. The water in glass diagram 9 has mass 0.2 kilogram. Initial temperature 50. Some ice cube have melted. We look at the question. Calculate heat absorbed by ice cube. Mass of ice cube has melted. Okay, heat absorbed by ice cube equals to heat released by water. Okay. So when heat released by water, that causes the melting process to occur. So you can see initial temperature of the water is 50, and then the final temperature is 0 degrees Celsius. So we have Q equals MC theta 0.2 4200 50 minus 0. We get 42,000. Okay, this one is heat released by water. So we assume that final temperature when ice melts. Okay. So mass of melted ice. Mass of melted ice means heat absorbed by ice equals to heat released by water. So heat absorbed by ice, we can use this formula. Q equals to ml for the fusion process of melting. So you have formula Q equals to ml. Fusion process. Thus, heat released by water equals to 42,000 equals to mass of ice melted and latent heat of fusion of ice. Okay. So we get the value of mass equals to 42,000 divided by 3.34 times 10 power 5 equals to 0.1257 kilogram. Okay, state one assumption. Normally in topic heat, there's only one assumption. There is no heat is lost to surrounding. Or we can say that all heat released by water is absorbed by ice. Okay, part D. Table 9 shows characteristic of 4 refrigerant panels PQRS that contain coolant agent flowing through the condenser pipe for use in the refrigerator. The PQRS has specific latent heat of vaporization, boiling point, shape, and specific heat capacity. This one is for cooling agent, this one for condenser pipe. For specific latent heat of vaporization, so we want the cooling agent able to absorb a large amount of heat energy. Okay, so means the specific latent heat of vaporization should be high. So I will remove the low one. Boiling point must be low, so that easily change to steam. Shape must be coil. Okay, this one for the condenser pipe, cooling effect must be higher when it is coiled, so that larger surface area exposed to surrounding. Okay, specific heat capacity must be low. Okay, so from here I get R. Means I just explained that specific latent heat of vaporization is high, boiling point is low, shape is coiled, specific heat capacity low. Okay, so for this one, okay, the question is explain suitability panel feature for cooling of refrigerator most suitable. Okay, cooling panel, give reason for your answer. This one normally we write in table form. Specification you must write I spec in the table form. First we have the cooling agent. I write down the spec. The second aspect is about boiling point of cooling agent. Third aspect is about shape of condenser pipe. And then the specific heat capacity. Specific heat capacity. Okay. Characteristic, now we can add in specific latent heat of vaporization of cooling agent must be higher. You can just compare word. Actually, we compare between PQRS. Boiling point of the cooling agent must be lower. Shape of the condenser pipe must be coiled. Specific heat capacity of condenser pipe must be lower. Okay, now we write the reason. Okay. Specific latent heat vaporization of cooling agent is higher. Okay. To absorb large amount of heat. During change of this boiling point of cooling agent must be low so that easily change to gas. When absorb heat. Condenser must be coiled so that larger surface area and increase rates of cooling so that the cooling agent can be cooled down faster. Specific heat capacity of the condenser pipe is lower. Sama juga ni. Lower specific heat capacity means there's a mistake here. Cannot remove. And we'll change the question. Thermal conductivity. The pipe cannot have a small specific heat capacity, so we change this one to, if not, there's no answer. And then this one is, maybe this one will just put as low. Okay. There's some mistake for that question. For the cooling timer, or to cool down the cooling agent, so it can release the heat out faster to surrounding. The here out is chosen because high specific latent heat of vaporization one. Coil pipe. And then high thermal conductivity. Of condenser. Okay. Soalan ni memang ada problem sikit lah. Ada correction lah. Okay, we look at number 10. Diagram 10 shows 14 barometer, atmospheric pressure. Look at the structure, scale, vernier adjusting screw, vernier, protecting tube, mercury, pointer. Okay. What is the meaning of atmospheric pressure? The pressure that produced by collision of air molecules with the objects in atmospheric layer. Okay, the pressure that produced by collision of air molecules with object in atmospheric layer. So we call it atmospheric pressure. Okay, B, referring to diagram 10, explain how 14 barometer can be used to measure atmospheric pressure accurately. Okay, first use adjusting screw below to change level of leather bag so that the pointer touches the mercury level. Okay, when bring to some place, maybe the pointer does not touch the level of mercury due to change in pressure. So what we do, we just use adjusting screw to rise up or lower down the leather bag until the pointer touches the mercury level. The level of mercury by using main scale and vernier scale. You can see there are two types of scale there, main scale and vernier scale. The mirror is used to prevent parallax error. Thus, we get atmospheric pressure is determined by height of mercury or sum of reading of main scale and vernier scale. Okay, okay, we read again the question. Okay, this one is how to explain this 14 barometer to measure atmospheric pressure. Use the adjusting screw to change level of leather bag so that pointer touches, okay, the ivory pointer, the mercury level. The level of mercury in barometer is read by using main scale and vernier scale. The mirror is used to prevent parallax error. Atmospheric pressure is determined by height of mercury or sum of reading of main scale and vernier scale. Okay. Now we'll get next question. You are required to investigate characteristic of barometer to be used in 14 barometers. Explain suitability of each characteristic of barometer. Determine the most effective barometer to be used to measure atmospheric pressure. Give reason. So we have the pointer material, back material, protecting tube, extra measuring instrument. Okay, we look at the first one, material of a pointer. Material of pointer must not react with mercury. If you put iron, iron will react with mercury. Yeah? Mercury is the metal liquid. So instead of metal, we use non-metal, which is made of ivory. Yeah? Gading, macam gading gajah. Okay? Tulang lah. Okay? Ini je lah. Yes. Okay. You know, iron know. Material of bag, just now already mentioned in the first part, is made of leather. Protecting tube material is made of not glass, brass. Okay, extra measuring, hydrometer we cannot use. Hydrometer is to determine the density normally. So thermometer to determine temperature. Temperature is the factor that affect pressure also. So just add in one more extra measuring instrument. We can put thermometer. So from here we can see X will be chosen. Explain in table form all the aspect. Material of pointer, material of bag, material of protecting tube, okay, for the pointer it made of ivory atau gading. Made of leather. Material of protecting tube, made of brass. Extra measuring instrument, thermometer. Okay, write the reason. Ataupun durable, tahan lama, tak mudah pecah sebagainya lah. Material of bag is leather. Okay, sebab dia strong and flexible. Easy to push mercury. Protecting tube made of brass. Brass is stronger. You can put your answer as strong. You can see does not break easily. Because we need to bring the 14 barometer to different position, maybe high place. So we don't want to use the glass one. So a brass not easily breaks. Okay. Extra equipment, thermometer. Okay, to detect change change in temperature for accurate measurement of pressure. Because temperature will affect the value of pressure. So this one, X is chosen because, okay, right again, pointer is made of ivory, leather bag, brass protecting tube, thermometer is used. Is added. Okay. Okay, normally I suggest to write in table form. 3 column. The first column aspect, second the modification made and explanation. This is not modification. Okay, I want to write for section B dulu. 10. Ini karakteristik. Okay. Saya nak tahu reason. Okay, now we go to part E, calculation. Atmospheric pressure, sea level 76 cm mercury. Atmospheric pressure in 30 cm mercury. Okay, density of mercury. Okay, density of air. Okay, calculate atmospheric pressure at sea level in unit of millibar. Using the formula P equals to HOG 76 cm mercury means the height is 0.76, density of mercury G 81. Okay. You get in Pascal. Change to millibar means 1.014 10 power 5 divided by 100. 1.014 times 3 millibar. Okay, determine height because on the top of the mountain, atmospheric pressure equals to 30 cm mercury. Change to Pascal means 0.3 13600 times 9.1. Okay. And this one equals to pressure due to air, height of air. Air here, density is 1.3. So we can use the formula H for G also. But H is height, represent height of air from the sea level to the top of mountain. So H 1.3 times 9.81 equals 0.3136009.81. Okay, so we get so H equals to we get 3138 meter. Oh, so need to, this one is for the top of mountain. So at sea level 76 cm mercury. Okay, means something like this. Here is 30 cm mercury. Here is 76 cm mercury. So the height is from here to here. So the value of the height of air here is caused by change in the atmospheric pressure. So we need to calculate for that, which is 76 minus 30 is 46. Okay. 46 cm mercury maksudnya ialah 0.46. Okay, so we get 4812 meter. Okay, section C. Diagram 11.1 and 11.2 show two electrical circuit containing two identical same resistance connected to different type of 1.5 volt dry cell. Magnitude of current flows indicated by the reading of ammeter. What is the meaning of current? Okay, rate of charge flow. Okay, based on diagram 1.1, 11.1, 11.2, compare type of arrangement, type, brightness or bulb, magnitude of current, relate type of arrangement and current, deduce relationship between arrangement and effective resistance. 5 marks. I will write here the answer. First, you want to compare between arrangement. So you can see the arrangement here is series parallel. Ini series. Sebelah menyebelah series. Bertentangan macam ni. Parallel. Okay. (11.1) is series arrangement. And 11.2 is parallel arrangement. Okay, itu yang pertama. Yang kedua ialah compare brightness. Brightness in 11.1. Tadi kita start lah 11.1 lah. 11.1 nampak cahaya dia mana lebih. Okay, 11.1 is dimmer. Tapi 11.2 is brighter. Okay, dan in 11.2. Third one, current flows. Current in 11.1 is smaller than in 11.2. Okay, now you want to relate. Okay, when arrangement is parallel, current is higher. As we know that current and resistance inversely proportional. Effective resistance in parallel is smaller than effective resistance in series. Okay. For parallel arrangement, effective resistance is smaller. Okay. Okay, part C, show another identical bulb connected to parallel with bulb K. Tambah lagi satu. 11.1 just now dia series, jadi you tambah satu across bulb K. Explain what happens to ammeter reading and the voltmeter reading across the bulb when switch is closed. Okay, apa yang berlaku bila you sambung situ ialah effective resistance dia akan decrease. Decrease, so apa berlaku pada current? Current increase. Okay. Voltmeter reading across K decreases sebab D depends on R. Ammeter reading decrease. Effective resistance decrease, voltmeter reading, decrease, effective, resistant across key. Okay, ammeter reading decrease, effective resistance decrease, voltmeter reading decrease, voltage across key directly proportional to effective resistance across key. Okay, tengok soalan seterusnya. Poor lighting in classroom causes student not able to study well. You are asked to modify classroom and the lighting system so that brighter, safer, able to save electricity. Kita ada 4 aspect here: type of connection, colours of classroom, type of lamp and colours. Ini dia dapat 2 1, 2, 3, 4, 5. So mesti ada 5 suggestion. Okay, write in table form. Okay, copy the aspect. Type of connection in colours of classroom, type of lamp and colour of light. Then we have additional component for safety. Okay, connection of lamp. Dari tadi series of parallel. Parallel connection. So that when one bulb is spoiled, the other bulb still function. Okay. Kalau rosak satu, yang lain boleh diguna. Color of classroom should be light or bright color, like white color, atau bright color pun boleh. It is a light reflector. So reflect back to the whole classroom. You don't copy above one, so that the classroom is brighter. Light reflected. Okay, type of lamp, kita guna LED. Sebab ini energy saver bulb. Low energy, consume. Ataupun energy saver bulb ataupun high efficiency bulb pun boleh. Color of lamp light should be easily reflected to brighten the room. Okay, additional safety, we can put something like fuse. Okay, so kita ada 5. So fuse dia akan break the circuit kalau ada excess current flow atau ada current leakage. Okay, ni ada 5 suggestion. So my suggestion is writing this way lah. Okay, but it's up to you. If you want to use 2 column also can. So I think that's all for now. Paper 2 Terengganu. Bye.